Thank you. So I hope everyone can hear me. So going back down from literally the bird's eye view of data from space and from the air, we're going to talk about individual edits in OpenStreetMap. And the motivation for this talk and this research project is this kind of thinking about, well, how usable are geoweb applications, and specifically going past the passive kind of viewing, zooming, panning, and looking at data and geographic data, but actually actively contributing to the data set. And this is hard. GI concepts are multiple, novel, and complex to novice users, resulting in a high cognitive load, especially if you go beyond the simple map, pan, zoom, looking at data approach and trying to implement data contribution functionality. And in the past, this has been confined to traditional GIS applications. And due to multiple factors, most traditional GIS desktop software packages today are hard to use for novice users. You need training, you need practice, daily practice to be able to use them and to use them efficiently. In parallel, over the past 10 years, GeoWeb applications have become ubiquitous and have entered a wide consumer space. So Google Maps is perhaps the best example of popularizing the use of and the consumption of spatial data by non-GI experts. And these are now starting, these GeoWeb applications, to implement more advanced concepts and functionalities, going beyond simple navigation to spatial queries, find me the nearest restaurant, the nearest Chinese restaurant, thematic formatting. So there's multiple examples now of GeoWeb applications where users can actually influence the thematic formatting, and spatial editing. So how do we go from this interface, loads of icons, you need training to use this software package, this is Esri, and if you put someone without any GIS experience before in front of the software package, you won't be able to use this efficiently. Going towards something like this, for example, GeoCommons is a really nice example of a GeoWeb application that's implementing much more advanced functionality in terms of thematic formatting, in terms of implementing good cartographic practice in a GeoWeb application, in terms of visualizing different layers of data. And this is actually quite a nice example of actually usable GeoWeb application. And how can this be applied to OpenStreetMap? So the motivation for looking at OpenStreetMap specifically was, although OpenStreetMap has achieved mass adoption, you could argue, in terms of the consumption of its data and its services. So there's, it's used millions of times, Microsoft, MapQuest, they're all bought into using OpenStreetMap data and trialing at least on their own map data sites. But what about actually people contributing to OpenStreetMap? And there is still this chasm of innovators and a very specific demographic, as Steve Coast earlier said, that we have reached in terms of editing the map and contributing data. But what about other demographics that go beyond kind of the early innovators that typically are the first to use new technology and interact with it? And this chasm is a very powerful concept of how, in a new technology, progress from the early innovators that use your technology, product, service, all through the early adopters, through the early majorities. How do you achieve mass adoption of, in this case, OpenStreetMap, not only as a passive service that people consume, but as something people actively contribute to? And one telling kind of fact here that I found was that of all the users registered for an OpenStreetMap account, so users typically don't have to have an OpenStreetMap account to consume the services. It's literally only when they want to contribute data that they have to open an account. Only 35% of those that register for an OpenStreetMap account go on to make at least one edit to that database. So somewhere in between registering for an OpenStreetMap account and then probably trying to contribute data, we lose roughly 70% of the users. So there is a problem there, and that's what we wanted to address by looking here. So how can we test the usability of the data contribution process in OpenStreetMap? So one benchmark is the child of 10 test. can a child of 10 years of age do something useful in 10 minutes? And this is kind of the ideal of universal usability, where it doesn't matter which demographic, everyone can and will contribute to the data. And it might be a bit simplistic, it might be a bit idealistic, but it is one benchmark. Then, so usability then refers to a quality attribute that assesses how easy user interfaces are to use. And usability engineering refers to methods for improving that ease of use during the design process. So what we're trying to do here is kind of evaluate usability of one of the most popular OpenStreetMap editors at the moment, which is Potlatch. But also, we also looked at the registration process. And try and measure it and develop some better idea of how usable the whole data contribution process is. And you can subdivide usability into 5 kind of components. So learnability, how easy is it for a first-time user to accomplish basic tasks the first time they encounter the design. And efficiency, how quickly can users perform tasks once they know how to do it. Memorability, if a user hasn't used a specific software or service for a while, can they go back to it and remember intuitively what it was they wanted to do and how to do it. How many errors they make, and how happy they are with using the service, how it makes them feel. Because kind of this is the first kind of study that has ever happened, I think, in terms of OpenStreetMap and its data contribution usability. We wanted to focus first on learnability. So what is it that makes those first-time users turn away from the software? So, as I said, in this study, we investigated specifically the usability of OpenStreetMap and Potlatch 2 specifically for contributing geodata. Originally, and if you looked at the abstract in the conference, we also wanted to look at Google MapMaker. But given the volume of data we got, from 10 participants using Potlatch, we got 12 hours of video feed of people interacting with Potlatch. We decided to not repeat the same experiment with Google MapMaker because it was too much data. We wouldn't have had the time to collect and analyze the data and so on. So we just focused on Potlatch. But at the end of my presentation, I will go back to try and compare with Google MapMaker some of our findings. So we took 10 participants with no prior online editing experience of OpenStreetMap. Some of them had GIS experience, some didn't. And we collected data. So we collected a screen and audio recording of the users interacting with it. And the concept of thinking aloud is very important here. So to make the user try and express verbally how they're feeling, what they're trying to do, what makes them frustrated, what are they looking for, and so on, which helps us a lot in the analysis of the data. Plus, then we did eye tracking. But basically what this means is we tracked where they look on the screen during the experiment to kind of see which are the user interface elements that are easy to find, where people look most, which areas of the screen people look most often on, as well as pre- and post questionnaires and observer notes. So the tasks were designed, so it was a tutorial. So the first task was register for an OpenStreetMap account, then find the editing functionality, add a pub, then add a road, then draw a building. So we built up the complexity of the tasks. There were, I think, 10 or 11 tasks in total. And to also repeat then adding a point several times so we can see as well if there's some measures of memorability of how to do things. Eye tracking sounds scary. You might remember from Stanley Kubrick's it does evoke these kind of images, but actually this is also more of an early eye tracker. Again, that child doesn't look too happy, I think. But nowadays they're really not obtrusive. Basically, they're built into a special monitor at the base, and they work completely passively. So the user hasn't to wear anything, any special glasses. And actually, now there's also eye trackers that work with mobile devices, so you can do usability and eye tracking on mobile devices as well, which is really neat. So, because I don't have too much time, I'll try and go over our main findings. And one framework for the analysis of results is Nielsen's heuristics. Nielsen is quite a famous usability expert. And he developed kind of 10 classes of usability issues that are commonly encountered within And he also offers specific improvement recommendations. We use this framework to kind of classify the problems we encounter and try and start to answer some of the questions, what's going wrong? Again, because of the talk and because of the amount of data we're only going to touch on a few of these. We went all the way through the design, implementation, and analysis. We were in touch with Andy Allen, one of the main Potlatch developers, and this is really not an exercise in criticism, but in trying to be constructive and also to try and help the Potlatch developers improve the design of the editor. So they already, we had an extensive, I think 2 or 3 hour meeting where we just showed Andy a lot of the videos. So obviously we don't have the time to do this, but I'll try and go over some of the main issues we found. So one of the heuristics is have a match between the system and the real world. What this means is the system should speak the user's language with phrases, concepts, words familiar to the user, rather than system-oriented terms. And also follow real-world conventions, be logical, be consistent, and have a clear order to processes and functionality. And one good example of this, very basic example, is the zoom functionality. So Google Maps kind of set the standard here with locating the zoom and pan functionality on the top left of the map window. And most interfaces adhere to that convention. So also in OpenStreetMap, in the view window, the zoom and pan functionality is on the top left. That's where user expected this. Using the eye tracking, we found that this was the case. So, but then you go to the editing window of Potlatch, and the users, and this is a gaze plot, so a heat map basically. Let me just explain this. So from the eye tracking, for each participant, we got eye tracking the tracks. And from several participants, you can build heat maps which indicate areas where they're most looking. And for the time frames where they were looking for zoom functionality, we can build this heat map of where they were looking for the zoom functionality. And it's quite clear that apart from the center of the map, which is very important and people look at most often, there's the zoom functionality is from users expected to find it on the top left corner, when in fact it is on the other side, on the top right. So already that's quite a clear indication that users are looking for functionality where it can't be found. So this is just one quote from one of the experiments on that. So not sure if I'm missing the obvious zoom and pan function. Ah, there they are, small and hidden. Same for the save functionality. Another convention, at least if you use Windows programs, often that there's a save functionality is on the top left of a menu bar where we save functionality. And again, Potlatch, the save function is on the top right. And we found that users looking for the save functionality were looking mostly on the top left, as you can see there on the heat plot. Interestingly also, most users didn't save their data after each task. One user didn't save at all, and I think most users saved 3 to 4 times during an hours-long edit, so it's quite a long time span between saving. Yeah, again, some quotes here. Am I supposed to click somewhere to save this? Oh, it should have saved right. Oh, top right. Whee! I was not expecting this to be in the top right-hand corner, I suppose. So another thing is user control and freedom. Users often choose system functions by mistake, and they need a clearly marked emergency path to leave that unwanted state. But even better is if problems can be, if a careful design can prevent the problem from occurring. One example of this was the panning, and I'm just going to try and quickly show you a video, if I can find it. Yeah. And I hope that the sound works as well. Oh, only one.
Need to zoom in a little bit more. Flutter there. Okay, so that's Gower Place. Wait, I think so.
Watch out what he does now when he tries to pan.
Whoa, no. Undo. Okay, undo. Didn't mean to move that.
So basically what this shows is that the users, especially when panning in such a highly built up area as London, had real trouble And this was only one example, but there were numerous examples of where this happened, of people inadvertently dragging elements while trying to pan. And there's some quotes here. The basic problem here is a conflict between the cartography, the density of map features, and how you can initiate a pan movement. Because in a rural area where there's lots of areas where there's no features, it's quite easy to find somewhere to click on where you can drag without moving any features. But in a built-up area like London, it becomes quite difficult. Oops, I don't know. Basically, then another example is recognition rather than recall. The rule is that you should always make functionality explicit, easy to find, visible, and consistent. So for each functionality, you should have user interface elements that you can select to create that functionality. And then opposite to that is flexibility and efficiency of use. So for power users, you should provide shortcuts, keyboard shortcuts in this case, to speed up the interaction so that the system can cater to both inexperienced and experienced users. And one example here is where you can compare with Google Map Maker is one task was to edit the Cruciform building, which is a famous building in the UCL campus, and has one wing missing. So users were given a task to complete this building outline, to add this wing to the building. Most users didn't achieve this because they tried to draw a new building outline for the missing part. And then if, for example, they found the merge functionality and tried to click on the merge functionality. Now, everyone that uses Potlatch knows that actually the merge functionality only works on lines, and when two ways that are connected to each other at the end points are you want to merge, but it doesn't work on polygons. And most users actually gave up on this task because they couldn't find an easy way to add points to an existing polygon. And in Google Map Maker, for example, you can see there's little dots between, in the middle of each line here, that you can drag out to create more polygons. And I'm just going to skip over this. So the last thing I wanted to talk to you about is kind of a quick comparison between Google Map Maker and Potlatch. And so this is just a quick video I did of using Google Map Maker. And you can see, for example, they have a very consistent method for adding a feature. So let me just pause this. So the process is exactly the same for each, if you want to draw a point, a line, or a polygon. You first click on what you want to draw. Then you do a pre-selection, roughly, of what it is you want to draw. In this case, I wanted to draw a house. Now, the problem was, actually, house, as a class on its own, didn't exist. And I was trying to find, why isn't there, why can't I draw a house? And I ended up clicking on haunted house, because that was the only kind of class I found that, well, I might as well be funny and click on the haunted house. And then I found out that actually there's something different called, I think, is it home, that you have to type in home to find the right preset for just a general habitation where people live. And they didn't have, so the user interface here to search for the right feature type was not really good. So I then went on to draw the house, and this went quite well. I mean, you can see here that on your left, they give you tips on how to draw the house, which is quite useful, I think. And once you finish the building outline, it automatically pops up extended features to attributes to add to it. And it helpfully also already in the address fills out the road according to the nearest road that's next to the new feature you've drawn. So clearly a lot of thought has gone into this user interface and consistency. So let me just go back to my presentation, and I've got 2 more slides, and then I can take some questions. Oh no, I'm a Windows guy, so all this LibreOffice stuff here is just confusing me here. So basically, there's a consistency of concepts and terminologies in Google Map Maker that is not given in OpenStreetMap. So Esri, for example, is point, line, polygon. Google Map Maker is point, line, shape. OSM, it's node, way, and then closed way. What is a closed way? Is it a polygon? Is it a shape? Is it something else? So that's this already conceptual kind of fuzziness in terms of, because there's obviously no data type polygon for the users. Also, in terms of the editing process, so Google Map Maker, as I said, it doesn't depend if you want to add a point, a line, or a shape. It's the same process through. You select what you want to draw, you pre-select the rough attribute, you draw the geometry, then you edit the extended attributes, and then save feature. In Potlatch, it's a bit more confusing. So for a point, you can use the drag and drop functionality to add a point and then edit the extended attributes. In a way, you first draw the geometry, and then you say what it is. In an area, you say, well, it's actually the same as the way, but it's confusing. And also, the save is not explicit. It is kind of assumed that users, after several edits, will start to edit to do a save. So there's this balance here between kind of rigid process that guides new users versus the flexibility that allows more advanced users to be more productive. So some conclusions is, well, on this continuum from novice to expert user, you can kind of place different editors and different interfaces. And I think Potlatch tries to cater both to novice and expert users because of its functionality. But it introduces a lot of conflicts. And the Google Map Maker, I think, is more geared toward novice users and more specifically catered to it. So expert users might feel frustrated by this kind of really rigid process you have to go through for each feature you want to add. So the question is there room in OpenStreetMap for a more basic editor geared towards really novice users that want to do their first edit, and what would its design be? And yeah, so just to say that it's not easy. This was a really work-intensive process to go through. Usability needs a constant feedback loop between designers, usability experts, and the users. And usability testing can be done easily, but it needs time to do. And what we want to do is to more robustly evaluate other interfaces like Google Map Maker, but also other interfaces like traditional GIS interfaces. And also, ideally, we would like to introduce other devices. So how do people edit and add data on a mobile device, for example, in comparison with the desktop computer? So this is, in a nutshell, what I want to try to say to you. I hope there will be room for a couple of questions. Yeah?
So, didn't the user use the browser keyboard?
No. Most users didn't find out that there were these keyboard shortcuts because they're not exposed in the user interface. And the help functionality, actually, people had real trouble locating the right help page to find those keyboard shortcuts. I think for novice users, keyboard shortcuts are not a good thing to do. Any other questions? Yes? It was just between me and Kate, but Mookie, he gave us support in terms of time, and also computer science, they gave us the usability lab to do it. Any more questions? No, up there, there's one more. Come on. Yeah, you're asking about JOSM. Yes, we'd like to, as I said, extend this to other interfaces. JOSM could be a candidate for that. Obviously, it's much more geared towards expert users. So I don't know if I would want to let loose completely novice users on JOSM. Okay, well, thank you very much.